Thank you all for coming. My name is Alex Debris. This is data modeling with DynamoDB. I got a lot to cover here in about 60 minutes, so I tend to talk kind of quickly. So if you have any questions, I'll have Q&A at the end. I'll also be available afterward out in the hallway if you want to chat on any of this stuff. But just in terms of what we're going to talk about today, I want to cover four major parts as we're learning about how to work with DynamoDB. We'll start off with DynamoDB basics, just talk about terminology, vocabulary, key concepts, get us all the same foundation as we start to talk about Dynamo. And then my favorite part, I think the meat of the talk is from SQL to NoSQL, right? So if a lot of you have experience with relational databases, SQL databases, normalization, things like that, I think that section will be helpful in understanding how and why to model things and why we model things the way we do in DynamoDB. And then we'll close off with a few other key topics I think people new to Dynamo, just some tips I like to help out there around primary keys and handling write operations in Dynamo. All right, so who am I? I'm Alex Debris. I'm the author of the DynamoDB book. It's a comprehensive guide to data modeling with DynamoDB. So we're just going to get a taste today in this hour. But if you want to learn more about Dynamo, go check that out. Just one tip: if you go to the AWS Village in the Expo Hall, in the databases section, they have like a scavenger hunt type thing. You can get a free copy of the book. So go check that out if you're interested. Also, I'm an AWS data hero, and then I'm an independent consultant. So if you have training needs or data modeling needs with Dynamo, feel free to hit me up. I'd love to chat on any of that stuff. And with that, let's get started. So let's start off with DynamoDB basics. I always like to start off with some vocabulary, 4 key terms: table, items, primary key, and attributes. We'll work through this by way of an example that'll show up throughout this whole talk. So imagine we have an e-commerce application, something like Amazon.com, where customers register with their email address. You can see we have 4 sample customers here, myself and 3 others. All that data together is going to be contained in what's called a table, right? A DynamoDB table, similar in some ways to a relational table, but different in quite a few others as well, as we'll see. Now, if you look at those 4 records and you look at an individual record, such as this one, that's going to be called an item. So item, similar to a row in a relational database or a document in DynamoDB. Working with items is going to be very important. All your work with Dynamo is going to be working on these individual items, right? Now, when you create your DynamoDB table, you need to specify what's called a primary key, and every item in your table needs to include that primary key, and every item needs to be uniquely identified by that primary key. So in this case, on the far left here, you can see we have a primary key that's going to be email address. That's how we uniquely identify each customer, right? We make them sign up with an email address. That's how we identify them. And then in addition to that primary key, if you look on the right, we have other attributes on our items, right? You can think of these similar to columns in a relational database, but different in some ways as well. The key difference being you're not going to declare all your attributes on your DynamoDB table like you would with a relational database and its columns, right? So DynamoDB is schemaless, so it's not going to maintain the database schema for you outside of that primary key. So this doesn't mean you shouldn't have a schema. You should absolutely have a schema, but it's going to be in your application layer. So whenever you're writing to Dynamo, reading back from Dynamo, do that validation on that schema, know what you're getting there. It's not going to be enforced for you at that database layer. One last thing about attributes. Every attribute you write, including the primary key, but it'll include a type with it. And that type can be simple scalar values like strings. So if you look at first name, last name, right? Those are simple strings. You can also have numbers, binary, Boolean, whatever you want there. But you can also have complex values like lists and sets. You can see we have profiles here, and I have a few different profiles in my e-commerce account. You can think like my Amazon.com account. You can also have complex objects like maps if you want to have a blob of JSON or something like that. You can throw that in there as well. So the 4 key terms, I want to dive a little bit deeper into primary key because that's going to be really important as you're working with Dynamo, as we're going to see today. Again, you'll declare that primary key on your table when you create that table. You can't change it after the fact. And there are 2 different types of primary keys with DynamoDB. So the first one's called a simple primary key. It just has one element, a partition key. And the second one is what's called a composite primary key. This has 2 elements, a partition key, but also a sort key. So let's go back to our example we had before. Again, our e-commerce customers here, right? That's an example of a table with a simple primary key. It just has that one element outlined in red, partition key. It's named email address, and that's how we're uniquely identifying our users. Simple primary key is going to be good for more simple use cases, key value store, cache type things like that. But if you have a more complex application where you're retrieving multiple items in a single request, you're often going to opt for using a composite primary key. So here's a table with a composite primary key. This could, extending our e-commerce order, maybe, or our e-commerce example, this could be our e-commerce orders, right? So when a customer makes an order, maybe we throw it into this table here. You can see we have a composite primary key that has two different elements. So on the left, we have that partition key, again, just like we did with our simple primary key. That partition key is customer email, but we also have what's called a sort key, which is our order ID there. One last note, just on all these images, right? All these images are generated from what's called NoSQL Workbench. This is a tool from the DynamoDB team that helps you just model out some of your stuff. That's what I'm doing here. If you look at this, you can see there are 4 items here, but I want to call out the 2 on top there. Those are 2 distinct order items, so 2 different order items. But if you look at the partition key for that, those 2 items have the same partition key. So what NoSQL Workbench is merging that cell and indicating that they share the same partition key of this particular email address. And that's going to be really important when you're working with a composite primary key to have lots of items with the same partition key. You're sort of grouping items together with that. There's an operation called the query operation where you can specify that partition key and retrieve multiple items with the same partition key. So, if I want to retrieve all the orders for a particular customer, go view my order history, something like that, I could go to this, say, hey, give me all the items with a partition key, that customer email equals Alex Debris, and it's going to retrieve all those items for me. So that's going to be pretty important when you're working with Dynamo, especially with that composite primary key. And then just in terms of terminology, that's going to be called an item collection. All the items that happen to share the same partition key, we might call that an item collection. We'll be working on item collections a lot when you model with Dynamo. All right, so that gets us through basic terminology. Next, I want to go from SQL to NoSQL, right? And the biggest thing is a lot of people have deep experience with relational databases. Whether you learned it in school or at a boot camp or on your job, you learned normalized data modeling, you learned about joins, all these different things. And then we get into DynamoDB, and I think the 2 biggest issues I see with people coming to DynamoDB is, number 1, trying to model DynamoDB like a relational database and just bringing all those principles over and running into trouble there. Or the second biggest thing is people ask me, hey, why is this DynamoDB API so weird, or why am I modeling in this particular way? And so I like this section just to help you understand some of the context behind Dynamo and what's going on there. And what I like to talk about is just in 3 different parts, right? Goals, choices, implications. And what we'll talk about here is, when NoSQL databases were being created, especially DynamoDB, when that's being created, what were the goals that the DynamoDB creators were aiming for, right? What were they not getting from a relational database that they wanted to get from making this new database? And once we understand those goals, then we'll go and look at the choices, right, that the creators of DynamoDB, the product team there, the engineers there, what are the choices they made to help implement those goals? And that's in terms of, features they do implement or don't implement, the way they structure it behind the scenes, and just the way they sort of, the API they expose to you and what you can and can't do. And then once we know those choices from the DynamoDB feature team, what are the implications to us as data users, right? They made different choices than relational database creators, so how does that change how we model data in DynamoDB? So we'll start with goals, and again, just sort of where this NoSQL movement kicked off. We're talking like the late 2000s, that decade, where you have these really global scale applications, like Amazon.com retail, and they're having issues with Black Friday, Cyber Monday, Prime Day, with the relational databases scaling up for that. And so that's where you see the Dynamo paper come out, written by Werner Vogels and a few other people at Amazon.com, where they developed a lot of these principles. And what were the key goals that they were going for? First goal was around consistency, right? And really this is about consistency of performance. So I have a chart I like to show when we're talking about this. So put this chart up there. If you look on the x-axis, that's going to be data size, right? How much data do we have in our database? And as you go further out to the right on that x-axis, you're adding more and more data into your database there. And then on that y-axis, we have performance. You could think of this similar to latency, right? The higher you get on that y-axis, the slower your query is going to be, the slower your response. Now, if you have a traditional relational database, your curve is going to look something like this, right? It's going to go sort of up and to the right over time. And when you're playing around in your staging environment or it's released on that first day, everyone's loving it because the indexes fit into memory, the data fits into memory, everything's blazing fast, your customers love it, it feels pretty snappy. But then maybe you accumulate more and more data in there, and 6 months, a year, 2 years down the road, it's starting to feel sluggish, right? Customers are starting to complain, or you're starting to notice that when you use it, you need to investigate and say, hey, do I need a bigger instance size? Do I need a new index? Do I need to denormalize? Do I need to remove this access pattern? Because it just doesn't work, right? So you need to do some investigation, and then maybe you can fix it for a while, but at some point, you might just get so much data that you need to re-architect, re-platform, redesign how you're doing your data. So I think this is a pretty typical performance curve that you see with a relational database. In contrast, if you look at Dynamo and what they were aiming for with Dynamo, you're going to see a performance curve like this, right? So it's going to be completely flat. So the performance you get in your staging environment, day 1 of your application, year 2 of your application, year 10 of your application, it should be consistent regardless of the amount of data you have in your database. And data size is only one factor that sort of affects performance latency. I could also change that x-axis to be concurrent queries, right? How many concurrent queries am I running against my database? And I think same thing with relational databases. You see the more and more concurrent queries you're running against that, the more you start to starve it of resources, and you're going to get slower and slower performance there. So that's the first goal of DynamoDB, right? We want to get that same response time regardless of the amount of data I have in my database, the amount of concurrent queries I'm running against my database. Now, sometimes I show this chart, and my friends that are good with relational databases, really, really strong experts in that, and they say, hey, that chart's not fair. If you don't use this feature in relational databases, you don't use that feature, you model your data this way, you do different things, you can get that same performance in a relational database regardless of size or concurrent queries or anything like that. And I don't know enough to know if they're right or wrong, but I do know it does require a lot of expertise to know all that stuff and know what you can and can't do. So I think related to this, right, the Dynamo team says, hey, we want to have the same response time in our database without having deep expertise by every single person on what features you can and can't use for relational databases, right? Think of Amazon.com. They have these 2-pizza teams where 6 or 8 people are creating these giant features, and they can't have an Oracle DBA on every single team, or they can't roll up every decision to an Oracle DBA. So again, they want to give you that consistency of performance without having expertise on every single team there. And one way I like to think about this, there's a quote from a guy named Nelson Elhad, who used to work at Stripe. And he's talking about how he loves SQL databases, but one thing that's difficult about them is, right, they have this incredible feature surface area. They can do a lot of different things. And it's really hard for you to know as a database user what the operational implications of those features are, right? So some of them will scale really well, some of them won't scale really well, and it's hard to know unless you have that deep expertise. So I think that's that first goal with DynamoDB, right? We want consistency of performance. Second goal, we want predictability, right? When we talk about predictability, part of that is around performance, right? If you have this chart and you have that flat performance curve, it's pretty easy to predict what your performance is going to be. So absolutely, performance is one aspect of that predictability. But the second aspect is around billing, right? And the predictability of DynamoDB billing and just DynamoDB's billing model, I think, is interesting and unique compared to any other database. So let's talk a little bit about Dynamo's billing. If you want to sum it up in one sentence, I would say with Dynamo, you're going to be paying for reads and writes directly rather than just for resources, right? So if you think about a traditional relational database, you're going to be choosing an instance size, which means you need to choose, hey, how many CPUs do I need? How much RAM do I need? How much disk space? How much network I/O? All that sort of stuff. And if you're doing capacity planning and you have a sense of, hey, I'm going to have this many users, they're going to issue this many queries, the items or the rows are going to be this size, it's really hard to transform that into CPU, RAM, IOPS, all that sort of stuff. And maybe you can do some load test, but how well is your load test going to sort of model the real world, especially if we talk about that consistency of performance with a relational database? You don't know where you are on that curve, and are you doing enough concurrent queries to truly test this? Do you have the same patterns you're actually going to have? So I think capacity planning with a relational database is really hard to do, and often what you see is just sort of over-provisioning, because it's better to over-provision than under-provision. Then you get single-digit utilization on your CPU. You're wasting a bunch of money, hard to provision back down if you need to. So traditional databases, you're paying for these resources. With DynamoDB, you're paying for those reads and writes directly. So Dynamo is going to charge you on what are called read capacity units, RCUs, and write capacity units, WCUs. And again, they just charge you for reads and writes directly. So a read capacity unit allows you to read 4 kilobytes of data from your table. Write capacity unit allows you to write 1 kilobyte of data to your table. And now if you have a sense of, hey, I'm going to have this many users, they're going to have this many queries, the items are going to be this size, you can estimate how many WCUs, how many RCUs you need. You can have some error bounds and do some different things, but you can get a decent estimate of what you're actually going to use, how much that's going to cost you. But even that part of capacity planning is hard. You don't know how many customers you're actually going to have. You don't know how many queries that's going to issue. So another great thing about Dynamo, right, it has 2 different billing modes. The traditional billing mode, provision capacity, is sort of like provisioning instances in a relational database where you'll say up front, hey, I want to provision this many RCUs, this many WCUs. They'll be available for you on a per second basis, and sort of use it or lose it, right? If you get 85% utilization, that's great. If you get 8% utilization, well, you're paying for it anyway. But they also have an on-demand billing mode, a pay-per-use billing mode, where you say, hey, I don't know how much usage I'm actually going to have. What I'm going to do is just issue reads against my database, issue writes against my database. You send me a bill at the end of the month, and we'll go our separate way, right? And on-demand is going to cost you more than that provisioned capacity if you were thinking about that provisioned capacity on a fully utilized basis. But so many people are just not getting good utilization out of their provisioned capacity, where on-demand can actually save you a lot of money, in addition to just the time and complexity of thinking about how to provision this. The great thing about this also is you can switch back and forth between those 2 modes as you need to. So if you have no idea on day 1 how much traffic you're going to get, just throw it on demand billing mode, let it run for 4 months, and then figure out, hey, do I know how much capacity I'm going to use? I can flip it over to provision capacity at that point, or I can flip it back and forth as I need to. You can also scale up your provision capacity, your RCUs, WCUs, as you need to. You just can't do that with a relational database, right? But you can, if you scale up during the day, you hit your high points and you scale back down overnight, you can absolutely do that with Dynamo. So the best thing I love about Dynamo and the predictability, right, is I always tell people, do the math. Figure out, is it worth it to do provision? Is it worth it to do on-demand here? You can even do this on an access pattern basis, right? If you have an access pattern that's going to be reading a lot of data, maybe you're doing some sort of aggregation or something like that, you can get a sense of how much is this access pattern going to cost me? Or if I'm adding an additional index, how many more writes is that going to cost me? And figure out if it's worth it to you to do that. So DynamoDB makes it possible to do the math where you could just never do that with a relational database. Hey, how much is this additional index going to cost me? That's, you can't do that. So that's the second goal for DynamoDB, for NoSQL, is that predictability. The last goal is just around reliability, right? If there's one thing that can't go down, that you can't lose in your application, it's your data, it's your customer's data. You don't want your database going down, and you don't want to be losing data. The great thing about Dynamo is it's a fully managed service, right? And we've seen more and more managed services with databases recently. But I would say there's still a difference in how managed Dynamo is compared to other databases, right? If you have a managed relational database, that's great. But you still have some things that you need to handle, right? You need to think about what instance size you want and how to scale that up and down. You need to think about scheduling upgrade windows. You need to think sometimes about failover. If there's an instance failover, how do you fail over to another region, different things like that. Whereas Dynamo, you don't have to think about any of that stuff, right? With Dynamo, you provision your table, you say how much RCUs and WCUs you want, or you just say, hey, give me on-demand mode, and you get an API back, right? And when new features are rolled out, they rolled out a new billing mode today, I didn't have to upgrade my cluster or my table to do that, right? It's immediately available for me. If they have new features, you don't think about it. If there's failures behind the scenes, which I'm sure there are all the time, they're just transparently managing that for you. You don't have to think about that. So DynamoDB, truly a fully managed service, and very few outages in DynamoDB. I talked to people who have been around for a while with AWS, and the only outage we could come up with was, there was one in 2015, so we're talking 6 years ago at this point, there was an outage there. But other than that, it's a pretty rock solid service. A lot of things depend on it in AWS, so they care about it being up. But even if you are worried about an outage, right, you can use what are called DynamoDB global tables. So outages in AWS generally going to be isolated to a particular region that happens to fail. With DynamoDB global tables, you can set up your table in multiple different regions and in active configuration. So right, a write to one region is going to get replicated back to the other region. A write in that region get replicated back to the other region. So if there is a failure in US East 1 or whatever, you just flip it over to EU West 2 or whatever other region you're in and go from there. So again, high level, these are the goals that we're aiming for with NoSQL, right? This is what relational databases weren't giving us in certain ways, that consistency of performance, predictability around billing, around performance, and then some of the reliability as well. So now that we know those goals, that's what they're aiming for, right? What are the choices that that team made in designing DynamoDB, in the API they give you, in how you need to model your data, things like that. So let's talk about the choices with DynamoDB. The first one is going to be around the importance of that primary key. So if we go back to our table with our composite primary key, right, this is our e-commerce orders table. It's very easy for me to go to this table if I have a customer email address and an order ID, and I can fetch that order, right? So you're going to query with that primary key. Or I can query just using that partition key and say, hey, here's a customer email address, give me all the orders for that customer. So that primary key, very important, particularly that partition key is really going to be crucial for you. But it's not as efficient to query with those other attributes, right? Those schemaless attributes that you haven't defined in Dynamo, it's not going to be very efficient to query with those particular values. And let's talk about why that's the case, right? And some of this is just getting into the nitty-gritty architecture of Dynamo, but I think helps build the mental model of how Dynamo works. So imagine when you provision your DynamoDB table, you might think of it being on some giant instance somewhere, but they're not going to keep all your data on a single instance. Behind the scenes, they'll spread it out across different nodes that they call partitions. Each partition is going to hold generally up to 10 gigabytes of data, right? So imagine I have a table here, maybe 15, 20 gigs of data. I have these two different partitions. Now, when this request comes into DynamoDB, let's say I want to insert a new order into my table. I do a put item request. That's going to insert an item. I have my primary key there. I have that email, that order ID. The first thing that's going to happen there is the request router is going to handle that. Request router handles all the requests for DynamoDB in a particular region. It's going to pull my table's configuration, see what the partition key is. It'll hash that partition key. So this email address comes in, it hashes that partition key, and then it does a lookup and figures out which partition it belongs to, right? So in this case, it says, hey, let's go to partition 1. We'll write that item to partition 1. And the great thing about this is I add more and more data into my table. I can add a third partition. I can add 6 more partitions. I can add 1,000 more partitions. But it's still going to be a constant time operation up front, right? So even if I have a 10 gigabyte table and I issue a read request in it, that read's going to come to that request router. It's going to hash that partition key and figure out which partition belongs to. That's a constant time operation, and immediately I'm going from a 10 terabyte table down to a 10 gigabyte table, right, to find my item. So that's what helps keep it so efficient, and that's why that partition key in particular is going to be so important. And basically, every operation you do in Dynamo is going to have your partition key, other than a scan operation, but most of them are going to require that partition key at the very least. So that's the first choice for you, right? The API that they give to you is going to really lean on that primary key pretty heavily. You're going to have to include it in your request. The second choice that Dynamo made is they have clear, harsh limits on what they can and can't do. And I think this is really innovative because your system, whatever it is, it has limits. And whether they're explicit, you know about it, and it hurts you, or it hits you at least with Dynamo. They can be explicit, or they can be implicit, and you just sort of hit it when you overload your system and it falls over. So Dynamo is very clear about the limits and what that system can and can't do. So let's look at 2 of these limits. The first one is the page size limit for the query and scan operation. So query and scan, these are 2 API actions that allow you to retrieve multiple items in a single request. That query that's the one that we talked about earlier, where you give it a partition key and it can retrieve a whole block of items from an item collection. So there's a 1 megabyte page size limit for query and scan. Let's go see what's going on here. We'll go back to our orders table here, and let's say I go to my order history table, and it looks it up by my email address and says, hey, grab those orders for Alex Debris. Returns those 2 orders. It's pretty snappy. And maybe that's quick, early on, but what if I keep coming back to this site, making more and more orders over the weeks, months, years, things like that, and over time, I have a lot of orders, right? I have a lot of order history. I go to that order history page, and now it's saying, hey, fetch all these orders, and that could be unbounded, right? We don't know how many orders are there. It could be a few kilobytes of data. It could be a few megabytes of data. It could be a few gigabytes of data. And DynamoDB doesn't like unbounded, right? They want to give you consistent, predictable performance. If this is gigabytes of data, now it's not predictable, right? That could be who knows how long to get back to you. So rather than read all those items back and just send whatever happens to be there, it's going to cut you off at a megabyte of data. So it'll read a megabyte of data during that query or that scan operation. It'll stop at a megabyte, and if there are still items to return, it's going to give you your items back and give you a pagination token. You can come back and get those additional items if you want to. So again, it's keeping your performance of a single request within particular bounds. It's giving you consistency, predictability that way. So that's the first limit of Dynamo. The second one I think is really interesting as well, and this is partition throughput limits. And we talk about predictability and especially reliability of Dynamo. I think this really protects your system as a whole and sort of protects you from yourself. Because we talk about managed databases again, and actually all these managed databases services are pretty good to where the service as a whole doesn't have an outage. But with a lot of managed databases, you can operate on your database in a specific way that will take down your database, right? And I've done this personally with Elasticsearch many times, right? Where there's nothing wrong with the managed Elasticsearch service, but I'm just hitting it with so many requests that all of a sudden Elasticsearch falls over, we have to rebuild the index, everything's down for a while. Dynamo wants to protect you against that. So they do this via partition throughput limits. Let's go back to what we were talking about with partitions before, right? Where that request router is figuring out to which partition we want to go to and operating in that partition. And imagine you just have a lot of requests go to a single partition, right? You're just overloading a single partition. Maybe all your data is sort of grouped together in an inefficient way. You have a lot of requests. That could, at some point, just overload that partition, right? Because that node, whatever it is, it has a limit beyond which it can't exceed. So rather than sort of leaving it up to you and rolling the dice to figure out where that limit is, they're just going to give you a harsh limit and say, hey, on an individual partition, you cannot do more than 1,000 write capacity units or 3,000 read capacity units per second. And again, this is per second on an individual partition, right? So each partition can do that. And you know, it's a pretty good amount of data there. You can view 1,000 writes, 3,000 reads of that. But if you exceed that on an individual partition, it's going to throw some of those requests back at you and say, hey, you're exceeding your partition throughput limits for this particular partition. Wait a second and try again there and throttle that back. And what this does is, again, it prevents you from taking down your database as a whole. It protects the overall at the expense of a few requests there. So that's the second choice they made, you know, these clear harsh limits for you in Dynamo. Third choice they made is they removed some features that don't work super well or don't scale super well, right? So we talked about a few of those. So with Dynamo, I think the most important ones that people miss are there are no joins in DynamoDB. There are no aggregations in DynamoDB. And it goes back to that quote we had with Nelson, right? Where relational databases have a lot of features, but it's hard to know the operational implications of those features. And these are features that generally tend not to scale well if you're not careful about them. So let's look at this relational database query, right? If you look at the top line, select sum, we're doing aggregation, right? We're summing all the order amounts for these orders that we're finding from the orders table. We're joining the customers table with that orders table, right? So we have an unbounded number of orders that we have to sum up. We also have an unbounded number of orders we need to join on. Then we have a filter clause. And you can say, hey, why can't Dynamo support this, right? If I go to this table, I have my 2 order items, why can't I just look at those order items, aggregate those up? It's going to be $89 or whatever, and return that back to me. And again, this is simple with 2 items, but what if we have a lot of items, right? I keep coming back over and over again, and now you have some unbounded number of items that I have to perform this aggregation over, and Dynamo, again, doesn't like unbounded, so it's going to prevent you from doing that. So Dynamo does not do aggregations for you at all. It just won't, it won't let you do that. So those are the 3 choices with Dynamo, right? So we have those goals we were aiming at. Here's the choices the DynamoDB architects and product team gave to us, right? The importance of that primary key, particularly that partition key, doing all that work to figure out which partition we're working on. Then we have those clear harsh limits, and then finally removing some features that don't have great operational performance for us. So now that we know about the goals, we know about the choices, what are the implications to us as data users, right? So far we've talked about everyone else so far, but now it's up to us as data users to model our data correctly in Dynamo. And so what are the implications coming from these features? And let's talk about some of those implications. The biggest one is it moves a lot of the hard work up front in the data modeling. And we've heard a lot about shift left on security and testing over the last couple of years, you know, where you move some of that stuff earlier on in the process. You think about security, you think about testing earlier on. I think Dynamo shifts left on scalability. It makes you consider how your database is going to scale. It helps clarify some of the business requirements and the trade-offs if you find something that won't scale super well. So just a few ways this manifests itself. Number one, you're going to design your table for your access patterns rather than in a more sort of abstract, generic way, right? So if you have a relational database, you're generally going to sort of model out your normalized tables without thinking how you're going to query them. You'll connect them via foreign keys, things like that, and then you'll think about your queries. Maybe you add some indexes, you write that SQL query to do that. But with Dynamo, you can't really design a table until you know your access patterns. And some people all the time say, hey, what do you think of my Dynamo table? And I say, I have no idea. Like, you don't tell me how you're going to use it. So come with that first and think about that, and then you're gonna model your table for that. So be explicit with that too. Like list out every single access pattern. Don't just think generic, like, oh, I'm gonna need to fetch the user a little bit, something like that. Like be explicit, write out every access pattern you have, and then make sure you're modeling your table for that. Second implication there is you're gonna need to maintain aggregations, right? Dynamo doesn't provide aggregations we were talking about before, but that doesn't mean your customers don't care about aggregations anymore, right? You might need to aggregate some data for your customers in certain ways, and you need to think about how to maintain that, right? Maybe you're maintaining a sum for a particular customer or something like that, or maybe you're maintaining a rolling average or something, or maybe you're just saying, hey, when that aggregation need comes, we're just gonna scan all the data, maintain that aggregation ourselves, and we'll handle the latency and the read costs that come with that. But you need to think about how you handle those aggregations rather than relying on this query planner to handle it for you and then finding out 2 years later that it doesn't work very well. Another implication is you need to think about pagination. You need to think about sorting, right? And pagination is sort of in the context of that 1 megabyte limit, right? You need to think about how you'll handle pagination there. But a lot of times you're not gonna page a whole megabyte at a time, but you need to think, you need to lay out your data in a particular way that's sorted the way that you want to paginate. And we'll talk about a little bit more about sorting in a second. And then last thing here, you might need to shard your data in certain ways, right? So if you're gonna hit those partition throughput limits, if you say, hey, I need to be able to support more than 1,000 writes for this particular partition key or more than 3,000 reads for this particular partition key, you might need to shard your data and think about that up front rather than sort of run headlong into it later on. So that's the first implication, right? You do a lot more hard work up front, but then it just sort of runs on autopilot for you. You don't have that long-term maintenance like you do in a relational database as it starts to slow down. Second implication, you're gonna use secondary indexes. This is a great feature from DynamoDB. I love it. So let's talk about secondary indexes and why you would need them. Let's go back to our table with our e-commerce orders in it, and it's very easy for me to come to this table and get a particular order if I have the email address and the order ID. It's also very easy for me to come here and get all the orders for a particular email address. But I can't come to this table and say, I just have the order ID. Can you fetch that order for me, right? Because that partition key is used to partition out that data. If we don't have that partition key, we don't know which partition that data is on, right? So what if I have additional sort of exclusive or non-overlapping access patterns? How do I handle that? That's where secondary indexes come in. What you do is you declare that secondary index on a table, and it's gonna copy your data for you from that main table into your secondary index with a new primary key that you define. So in this case, I might declare that primary key on that order ID value and say, hey, make that my primary key in my secondary index. Take a look at our secondary index here. This is the exact same data. The big key is it's just structured in a different way, right? So now our primary key is just that simple primary key, just has a partition key of order ID. I can go to that secondary index and get this particular order by that order ID if I want to. So secondary indexes are gonna help you with additional access patterns on the same piece of data, right? So let's just summarize that up again. Again, what's happening here is data from your base table is getting copied into your secondary index with a new primary key. And once you have that secondary index, you can issue read requests against that secondary index. You can do query, scan, things like that against your secondary index. However, you can't do writes to your secondary index. All the writes have to go through your main table and then are gonna get replicated out to those secondary indexes to enable additional read-based patterns. We'll talk about the implications of those last two things in a sec as well. All right, so far I think this is fairly straightforward. It's gonna get a little bit weirder now. Next implication is you'll often use generic primary keys in DynamoDB, and if you've heard of single table design, if you've seen a single table design out in the wild, this is where this starts to come in. So let's talk a little bit about single table design. We'll just sort of modify that example we've been working with so far, right? So we've been doing this e-commerce application. We've had two separate tables. We had our customers table, we had our orders table. We're gonna model these customers and these orders in the same table, right? So with DynamoDB, you might put multiple different entities in a single table, something you probably wouldn't do in a relational database. So let's take a look at this. We'll start with some customers first. So here are two customers in our table, myself and Jen's sample. Two things I want to call out here. If you look at that primary key, and especially look at the names for those primary key attributes, they're very generic names, right? Instead of having customer email or first name or last name, whatever, I have these generic attributes. PK for partition key, SK for sort key. And the reason we're doing this is we're going to have different types of entities in that table there. And they're going to have different attributes, right? This customer is not going to have an order ID associated with it. An order ID wouldn't have a first name associated with it, right? So certain things aren't going to apply across different entities, so we give it these generic names here. Also, if you look at the actual values for these primary key attributes, look how they're weird, right? They're smashed together multiple different things. You might have multiple attributes in there. You might have sort of the type at the beginning of this. You can see in all caps users, and then a hash, and then the email address. Same thing for the sort key. And we'll see a little bit more about that in a second. So here's our 2 customer items. Let's add some order items in here. Here we have our table. I still have those 2 customers there. They're outlined in red there. But we've also added these 3 order items into our table as well. A couple things I want to call out here. Look at the sort key for that order item, right? It uses a different pattern than the customer item does. So here we have order, hash, and then this giant random string, right, to identify that order and order ID as compared to that customer item. Second thing about this is just look at the different attributes we have on our customer item versus our order item, right? Customer item has things that matter to the customer, first name, last name, profiles. Orders have things that matter to the order date, order amount, order status. And because DynamoDB is schemaless, we don't have to declare those attributes. We can put whatever we want in there. Again, validate that in your application, but Dynamo is not going to validate that for you. Last thing I want to call out about this, and we talked about item collections. We talked about multiple items with the same partition key. And if you look at this right here, right, we have 3 different items that have the same partition key. But this is unique because we actually have heterogeneous items here with the same partition key, right? So we have this customer item up top, but then below it we have 2 order items. They're all in the same item collection, have the same partition key there. And what this might enable, maybe we have an access pattern that says, hey, fetch all the orders for a particular customer, and we can do that. But as part of that, I also need to fetch that customer item, that parent customer item. Maybe I need to enrich the orders with something about that customer or whatever that is. And you would do that in a join in a relational database, but we don't have joins in Dynamo. So what we're doing is pre-joining our data in a way that optimizes for that read access pattern, right? So we're putting those all together. Again, that's going to be called an item collection. You can even put heterogeneous items in the same item collection as we have here. All right, so that's where it gets a little wild with that single table design stuff. Last major implication we're going to see, I think this one is also pretty hard for relational people, but you have to get comfortable with some amount of denormalization. And this is tricky because normalization has a lot of benefits. It's something we've all, not all of us, but a lot of us have learned about how to do normalization. And this one's hard to let go, but I think there are a few places where denormalization can be really effective with DynamoDB. One is just using complex attributes. So we talked about how Dynamo can support lists, sets, maps as attributes. And let's see how that might be useful. Let's go back to our customers in our e-commerce table here. And maybe our customer that signed up for our e-commerce application has multiple addresses. They have a home address, a business address, a parent's address, something like that. And what we might do, we could store those as separate items, but we might just store it as a complex attribute on that customer itself, right? So here we have this map attribute. It has a couple different addresses there, home, business, whatever you want to have there, and you can store that. And because we're almost always going to be accessing those addresses within the context of that customer, we don't necessarily need to split those out as separate items right there. We can keep it all together. It makes it a more efficient operation when we're reading that customer, reading those addresses. So you might do that, right? Rather than split those out as separate items or in a separate table with that foreign key relationship like you would in a relational database, just throw it on there. A second time you might want to denormalize your data is just duplicate some information from across multiple items, right? Again, you wouldn't do this a lot in a relational database, but it might be common where if you have a one-to-many relationship, maybe you want to duplicate some information on that parent item from that parent item onto those child items. It can save you reading that parent item in certain instances, right? Make it more efficient for you that way. I think the big thing here is don't go wild with this. Like, you need to weigh the costs and benefits of denormalization versus normalization. How often are you going to be updating that attribute? How many items is it spread across? How hard is it going to be to make those updates? Do I need to do that in a transactional way? So you need to weigh those costs and benefits, but there are certain times when relaxing the rules around normalization can be really effective for you. All right, so that closes out from SQL to NoSQL, right? And again, we talked about the goals for that NoSQL movement. We talked about the choices they make as a DynamoDB team and then the implications for us as users. I want to cover a few other key areas and just places I see new people in Dynamo get tripped up a lot. And primary keys is a good one because it's going to be so important to your data modeling. So let's talk a little bit more about primary keys. The first one is, we talked about those generic primary keys, how weird that can look and what's going on there. I think when you're looking at your DynamoDB items and planning those out, I like to split the item into what I call application attributes and indexing attributes, right? So they're two separate things. Again, let's go look at our table here with our e-commerce orders, actually with our customers and our orders. If you look over, on the right side of that application, we have of this table, we have attributes that matter in our application. First name, last name, profiles for that customer, right? And order amount, order date, order status for that order. That's what you're actually going to be operating in your application logic, right? Your business logic is going to operate on those attributes. If you return these to a client, right, in a REST API, those are the attributes you're going to return back. But those other attributes, PK, SK, right? I think of those as indexing attributes. And the only reason you put those attributes on your item is for DynamoDB, for efficient indexing in DynamoDB. You're only doing that to make it easier to look up those items at read time with Dynamo. So these attributes will only go on, I would put them on only at the very boundary of your application, right before you're writing to DynamoDB, put them in there. Don't worry about that in the business logic part of your application. When you're modeling with Dynamo and planning it out, you're really going to be worrying about those indexing attributes parts. But once that's sort of done and settled, then in your application, you're going to be messing around with your application attributes. And this works for the primary key on your table, but it also works for secondary indexes, right? So let's add a secondary index. This is our same table here, but I've added some attributes off to the right. If you see what those are named, right, we have GSI1 PK, GSI1 SK. That stands for Global Secondary Index, right? We talked about secondary indexes. Global Secondary Index 1, because you might have multiple of them, 1, 2, 3, 4, whatever that is, and then PK and SK, just like you have for your primary key. And this isn't required, but I think these are patterns that you see a lot with Dynamo, is having that PK, SK, having those GSI1, PK, and SK. But again, think of those as indexing attributes separately from those application attributes that you have, that you operate in your application. So that's the first key around primary keys. Separate those mentally, application attributes from indexing attributes. Second thing is, we talked about two primary key types in DynamoDB. You're almost always going to use that composite primary key that has two elements, partition key and a sort key. Just in terms of how I think about those, right? The partition key is for grouping. The sort key is for ordering, right? So that partition key, again, it's going to decide which partition we go to, so it's going to group those together. If we look here, right, we've grouped some items together by customer email, and it could be heterogeneous items such as having that customer item, having some order items. But within that item collection, right, all those items that have the same partition key, they're going to be sorted according to that sort key. So let's talk a little bit more about that sort key. Again, key point here is that within a particular item collection, all the items are going to be sorted according to that sort key. So there's no sorting across partition keys, but within a particular item collection, they're going to be sorted lexicographically by sort key. Lexicographically basically means alphabetically, but all uppercase letters come before all lowercase letters. Numbers are in there, symbols are in there. Yeah. Big key takeaway here is when you're grouping items, think about how you want to order those results, And if you're working with heterogeneous items, think about where you want to place that parent item. If we have the customer item, we have some order items. Do you want that customer at the top where it's near the oldest items, or do you want it near the bottom where it's near the newest item? So think about that. Also, if you have pagination in your application, think about how you want to do ordering and sorting there. So a few different patterns you might see around sorting, right? Alphabetical, that's going to be a very common one. If you're sorting by usernames within an organization or something like that, you might use alphabetical. Key point here is the way the sorting works, all uppercase letters come before all lowercase letters, so I would recommend standardizing that sort key if you can have a mix of uppercase and lowercase, otherwise you might get weird sorting that you don't expect. So alphabetical, very common one. Another common sort pattern is by timestamp, right? Some create at, update at, something like that. So you can use epic timestamps, but you can also use ISO 8601 timestamps. They're big endians, so you get year, month, date, whatever. So they sort nicely, and you can also read them, which is great. So feel free to do that. And I'd say it's a third pattern you might see is, hey, I'm creating something. I need to give it a unique identifier like a UUID, but I also want sorting based on creation time, right? And you can look at things like ULID or KSUID, a few other implementations as well. But what these are sortable unique identifiers. So if we go back to our application that we have before, right, we have our customer, we have our orders. If you look at those orders, they each have an order ID in there. We can generate sort of whatever random ID we want, but we also want to be able to retrieve these in creation order. So when we're doing that order history, we can show them in the order that they are created. That's what we have here. We have a ULID. It's 25 characters or so. The first, 9 or 10 characters are going to be an embedded timestamp, basically, of when it was created. So they're going to sort very nicely for you. If you go look at the order date there, they're going to sort in ascending order based on when they were created. So check out that ULID, KSUID, if you have those sortable unique identifier needs. Last thing I would say about partition key and sort key, we talked about creating these item collections with heterogeneous items in there. I see people sort of overdo that a lot as they're new to DynamoDB. So the big thing I would say is only group items together if you're going to fetch them together in a single request. So let's go back to that example before, right? We have that item collection that has that customer item, has those order items. You might want to do that. You might want to say, hey, give me all the orders for this customer, but I also need that customer item to enrich something about those orders. This is a very efficient way to do that. But maybe instead you've duplicated some information about the customer onto those order items, and you don't need to fetch that customer when you're fetching those order items. In that case, don't feel like you need to put them in the same item collection. You can spread them out. This is the exact same data here, but I've just used a different partition key pattern for my customer items and for my order items to where they're not in the same item collection anymore. Two big benefits of this will be, hey, now you're spreading that partition throughput across different items. Your orders have one sort of some partition throughput, and your customers have a different one in this one. Also just makes your queries easier because you don't need to sort of filter out certain items if you're just returning a subset of them or something like that. It just makes it easier to do that. So don't go wild sort of overloading your item collections with heterogeneous items. All right, so for partition key for grouping, sort key for sorting. Last thing on that, you want to choose something with high cardinality for that partition key in order to distribute requests across your table, right? So we talked about those partition throughput limits before. If you have all your requests going to one partition, you might exceed those partition throughput limits. You want to choose a partition key that's going to distribute data across your table, right? Spread it across those partitions. You'll make use of the true sort of underlying infrastructure of DynamoDB and get a lot more throughput there. So choose something with high cardinality. You want to avoid things like enums, right? If you have 5 particular values across your table, I wouldn't recommend using that as a partition key unless you have pretty low throughput needs. All right, a couple more things about primary keys. Primary keys are going to be a great way to maintain uniqueness. So we talked earlier about how a primary key needs to uniquely identify every single item in a table. What you can do there is basically use that to make sure that primary key is unique. And what you should do there is use meaningful values in that primary key, right? Some people, they come and they want to move their relational databases over to Dynamo, and they say, hey, I already have a primary key. It's this auto-generated integer that they gave me when I put that record into my table. But that's not meaningful about your item, right? That's just an accident of sort of when you inserted it. But so you want to use something like an email address, a username, an order ID, whatever is going to be unique across that table, and you can use that to maintain your uniqueness on that particular attribute. Last thing about primary keys, you cannot update the primary key of an item. So if you issue an update operation against an item in DynamoDB and you say, hey, update this attribute, update the PK attribute, update the SK attribute, you can't do that. And the reason is that the primary key is like the essence of that item. That's how you identify that item. It's really tied with it. The place where I see this be a problem to people is if you have something mutable that you want to be sorting by, right? So if you want to sort by updated at, and you want to put that in your sort key, and whenever it's changed, then you move something up to the top so you get that right away. Or if you have a leaderboard, right, and you have a different game, you have a lot of people playing in there, their scores changing over time, and you want to be able to show the top 10 scores or something like that. So you can't do that in your primary key, but you can do that in your secondary index. So if you have a mutable value in that primary key, especially in that sort key, I think is where I see it come up the most, put that in your secondary index, and then Dynamo, when it's replicating out to your secondary index, it'll handle that operation on your secondary index to delete the existing item, insert the new item, and give you sortability on that mutable value. All right, that's primary keys. Last one, write operations, and then we'll take some questions and things like that. I always tell people, write out your access patterns first with DynamoDB, and a lot of times they'll write out their read-based access patterns and really focus on that. But I think in almost all cases, you should really start with your write-based access patterns for a couple reasons. So So let's walk through this. A couple points here. When you're talking about your write operations in DynamoDB, every time you do a write operation, you have to provide the entire primary key of that item you're writing, right? So if you're inserting, updating, deleting, you have to provide both the partition key and the sort key if it's a composite primary key. That means you can't do like an update where operation where you're saying update all the values with this partition key, or a delete where, delete all the values with this particular partition key. You can't do that in Dynamo. Have to provide the entire primary key. Additionally, all your writes have to use your main table, not your secondary index, right? So let's go back to this example, and I want to show how that can affect you here. May we have our customer orders, and when we're creating that order, we say, hey, we have the customer email, we have the order ID, let's put both of those in that primary key, and then I can also fetch orders by customer email there. So I might do that. But maybe later on when we're working that order in the warehouse or whatever, all we have is that customer ID. So we go pick that particular order, it's ready to go, it's ready to ship, and all we have is the customer ID, or the order ID, but we don't have the customer email, and now it's hard for us to do an update operation against that item because we don't have the email address for it, right? So in that case, it might have been better to use a primary key that just has the order ID in it. That would work when we create the item. It would also work when we're updating the item later on, and then we could have a secondary index where that was keyed by using the partition key of a customer email to allow for that read-based access pattern. So think about your write-based access patterns first in light of these two things. You also want to think about your write-based access patterns first to think about your constraints, right? When you have your application, you probably have some sort of business requirements, whether that's, hey, we need to make sure something is unique across an entire table, or we need to make sure when someone's doing this, they have proper permissions, or if there's an account balance, they can't do a transaction that would take their account balance below 0, right? So think of your constraints, and you're going to need to use your primary key in a lot of cases to do that. Let's talk about how you maintain constraints in DynamoDB. 3 different patterns here. First one, most useful, I'd say the one you want to do almost all the time is use a condition expression. So anytime you're doing a write operation in DynamoDB, you can include what's called a condition expression on that. And what's going to happen is the server is going to evaluate this condition expression before it does that write. And if that condition expression evaluates to false, it's going to abort that write and throw it back to you and say, hey, we're not going to do this right because that condition expression failed. So let's see where that might be useful. Go back to our table, right? We have our tables here. Some customer comes, they want to sign up in my store with my email address. I've already signed up with my email address. So when I'm inserting this customer record, I say, hey, insert this record, assuming there's no record with this primary key already. And if that primary key already existed, we know that customer email is already being used, and we'll reject back and say, hey, you have to choose a different customer email or log in with your existing one there. You can also do condition expressions on other attributes as well. So let's go back to that order example where maybe we're processing that order in our warehouse. We have, it's in the place status. We get all the orders. We have it picked. We get to put it in the box and ship it out. And we say, OK, this order is getting shipped. But when we do that, we want to assert that the current status of that item is placed, right, to make sure it hasn't been canceled in the meantime or to make sure someone else didn't already ship that item. So we want to assert that on that. And if it fails, then we'll go look at that and say, hey, why isn't this order in the status that we expect? So condition expressions, great way to do that. Downside of condition expressions is they only operate on single items. So whatever item you're operating on, whatever your item you're inserting, updating, deleting, you can only make that assertion against that particular item. You can't do assertions across items, across multiple items. If you do need to operate across multiple items, then you can use DynamoDB transactions. This is a feature that came out 3 years ago now, I think 2018 reInvent, and it allows you to do conditions across multiple items. And when you're working on those items, those operations will succeed or fail together, right? So let's see where this might be useful. Let's go back to our application. You remember I have this profiles attribute where I list a couple profiles. Myself, my wife Elsie, we also have a kids account. Maybe they can, it's Amazon. They can watch movies on that account. But maybe, even though we have these 3 profiles, we only want 2 of them to be able to actually make orders, right? So we have an admin profiles attribute. Myself, I can make an order. My wife can make an order, but the kids can't be ordering stuff. Now when an order comes in, we insert this order item, right? But that's a separate order that we're doing there. We also need to wrap that in a transaction to make sure, hey, whichever profile is making this order, make sure they're in that admin profile. Make sure they have permission to actually create this order. If they're not in there, then it'll get rejected and thrown back at us. That's a great way to use transactions to enforce some of these constraints there. So transactions, they're great for maintaining constraints across multiple different items. The big thing I would say here is make sure those items have pretty low contention, right? So when an item is being involved in a transaction, it's basically going to be locked. You can't use it for other operations. That can even affect other single item operations. So if you have a very high velocity item, you don't want to be engaging in a transaction a lot, or else you're going to get a lot of transaction conflicts thrown back at you. So if you do have the use case where you have really high contention on a particular item that you need to involve in a transaction, now you need to look into more complex patterns, something like a Saga, like a distributed transaction, maybe DynamoDB streams. If you're maintaining aggregations, you can do that downstream. If you want to know more about these, I would say check out Rick Houlihan's talk from last year's reInvent. He showed a lot of really cool patterns there. He also has a talk Friday here that it's always the best talk of reInvent, so make sure you go see that one. But Saga, DynamoDB streams, that's great for maintaining constraints. We have multiple items that have high contention. You don't want to involve it in an actual DynamoDB transaction. All right, so that'll close us out here. Just a quick summary of what we covered, and then we'll open it up for questions. We covered 4 things. Just starting off with DynamoDB basics, vocabulary, terminology, key concepts to put us on the same page. Then we did from SQL to NoSQL, right? And if you're coming from that relational database background and you're feeling, why is Dynamo so weird? Why do I have to model it so differently? Why don't they give me some of the features that I want? You understand the goals and the choices and the implications for you as from Dynamo in that part. And then we just wrapped up with some other areas that I see people get tripped up on a lot, primary keys, write operations, things like that. Thank you all for coming. I really appreciate it. I'm very available on Twitter, email if you want. If you have additional questions, we have 8 minutes to do questions here. I can take a few in the hallway as well, but feel free anytime, seriously, to reach out to me. So, any questions? Yeah.
So you talked about Dynamo maintaining those secondary indices.
Yep.
Saying it copies data from the primary table to the index. It sort of implies an ordering there. Like, is that the exact order in which Dynamo does this? Or does it write the secondary index first? Like how is that actually orchestrated so you get read and write?
Yeah, sure. So the question is, if you're using secondary indexes, what's the order that it sort of writes the index versus the table, and what sort of consistency do I get from that? So it's a little deeper than we'll cover here, but basically there are 2 types of secondary index in DynamoDB. There's what's called a global secondary index that you're going to use in almost all cases. There's also a local secondary index that's more rare. It imposes some limitations on you. If you're using a global secondary index, that's going to get eventual consistency. So it's going to write to your table first. Once that's acknowledged at the primary, then it's going to dump it in a queue to go replicate out to that secondary index. You'll get eventually consistent reads on that global secondary index. If you're using a local secondary index, you can get strongly consistent reads, but again, it imposes some other limitations on you. It has to be the exact same partition key that you've used for your main table. That's a big limitation because often you want to repartition in some way. Has to be made at table creation. Also imposes some item collection size limits on you. So I would say generally you're going to get eventually consistent reads on your secondary index. Good question. Any other questions? Yeah.
So about the single table design,
Mm-hmm.
usually in the context of a microservice, taking your example of users and orders, I may have a microservice for users, another for orders.
Mm-hmm.
And in that example, they would both share the same table?
So I would think of it as a single table design as sort of everywhere you would have a relational database, that's probably where I would have a DynamoDB table. So if you had 2 different services, they're probably not sharing the same relational database, right? The order service has its own relational database. User service has its own relational database. Same thing with DynamoDB. So you don't want to do cross-service data sharing, but generally within a particular service, it's not a hard and fast rule, but I would say often you want to have fewer tables within a particular service. Yep, good question. Yep.
Just sort of going with that, right? You talked about how on a single table design, right, you want things to be adjacent to each other or in the same item collection if you want to fetch them at the same time.
Sure.
But if you're not going to fetch them at the same time, what is the benefit of having a single table design instead of just having separate entities and separate tables?
Yep, that's a tough question. Like it varies a lot, and I would say that's going to be the biggest benefit of single table design is being able to fetch heterogeneous items, giving you that pre-join capability. Another thing about having a single table is you have a little less maintenance. You don't have to maintain sort of RCUs, WCUs, alerts on multiple ones. But if you're using on-demand billing, that sort of goes away as well. So I'm not as strict a single table stickler as some people are. But I would say the bigger thing is make sure you're modeling your data in a way that works for Dynamo rather than works for a relational database. So make sure you're thinking about application attributes and indexing attributes, things like that, and thinking, hey, I'm using some attributes to index my data, sort of separately than the rest, right? And I just want to fetch my data by those indexing attributes, and the rest of the blob comes around for the ride, and I can actually operate on that. At that point, like, it's pretty easy to do like, if you've done that, it's pretty easy to put them all in the same table, but it's also fine in some cases if you want to split them up. I'm not gonna fight you on it. So, yep, good question. Oh, hold on. Yeah, go ahead.
Am I able to query for ranges? Let's say date range,
Yep.
as opposed to just going by pagination and
Yep.
stopping that?
Absolutely. So the question is, can I query by date range? Yes. And I didn't cover the API super in depth, but that query operation you do, you need to include the partition key because you're going to be searching within a specific item collection. But then you can also have conditions on the sort key. So you could have, say you had a timestamp in there. You could say, hey, make sure my sort key is between May 1st and May 30th or whatever, something like that. So you can have conditions on that. The conditions on that sort key are basically, I like to think of the sort key as like a physical dictionary where you can sort, as things are sorted, so you can basically do prefix-based search. You can say everything before this, everything after that, everything between this range, but you can't say everything that ends with this particular value, everything that contains this. Just like you couldn't go to a dictionary and say, give me every word that ends in ing, right? You'd have to look at every single word. But yeah, you can do sort key conditions. You had a question over here?
So in case of a data read, like, for an existing system, I have different indices defined for different features. Like, for example, for feature one, I have a set of indices. In this case, like, so I designed everything is up there, and I got a feature which says, like, I need to fetch this set of data. So in a relational database, I create separate indices for it.
Yeah.
What do I do here?
Yep. So, and just to make sure I'm rephrasing this, what happens if I have new access patterns on existing data? Is that basically? Yeah, absolutely. So, I talked about how you want to design for your access patterns, do that up front. What if I have new access patterns for you? Well, it feels hard, but it's actually not as hard as you want, and it sort of depends on the migration you have. If you have, say your application's evolving, you're adding new entity types into your application, well, that's pretty easy. You don't have existing items in there. You do that same sort of planning around those things, but now when you write those in, you plan them for your access patterns. The harder case is the one you're bringing up where I have some existing data in there. Now I want to access it in a new way, right? So I have my customers in there. All of a sudden, I want to access them by last name. I haven't indexed them in that way previously. Basically, what you have to do is like an in-place ETL operation where you scan over your entire table. You identify the types of items that you want, right? So if I have a table with customers and orders in it, I don't need to do anything to the orders. But every customer I find, I need to take that, issue an update operation to say, hey, now the GSI1 PK is last name, the GSI1 SK is whatever. So I do that, and I add my secondary index if it's a new secondary index, or maybe it's not. And now that pattern works for you. So that's generally how it works. And that feels scary because it's like, oh man, I have to write some code rather than just sort of issuing a DDL command against SQL, right? But like once you have that general framework where you're like, okay, I scan, I identify customers versus orders, and I issue this update, like it's pretty methodical on how that works. So first one's scary, second one might be scary, but then you're kind of used to it. Does that answer your question?
Yep.
Okay, cool. Yeah.
The 4 KB limit, if for an item, if I run more than 4 KB, like how can I manage it?
So, so the question was the 4 kilobyte limit for an item. So actually, how can I manage it if I have an item bigger than that? Actually, the item size limit is 400 kilobytes. But what they'll charge you for, the RCU, is they'll charge you for every 4 kilobytes you read from your table. So if you have an item that's 18 kilobytes, they'll divide that, that's going to be 4.5, divided by 4, that's going to be 4.5. They'll round up and charge you 5 read capacity units to read that item. So you can have an item much bigger than that. You want to have smaller items because it's going to cost you less than RCUs and WCUs and things like that, but you can have ones bigger than a single unit. And when you're working with a query operation, if you're retrieving multiple items, what they're going to do is sum all those items together first and then divide by 4. So if you had a bunch of really small items, 100 bytes each, they're not going to divide each one by 4 kilobytes and round up to a read capacity unit. They'll sum them all together, then divide by 4 kilobytes, then round up. So query operation, very efficient for reads, especially if you have smaller items. Yeah?
You talked about choosing a primary key that's meaningful.
Yep.
Most of the times, like in an application, you kind of like expose an interface where you change the username or, for example, email, right?
Mm-hmm.
And that case, if you have like a single table design, right, where we were also like putting that username or email
into the secondary information like the records that we have.
Yep.
So how do you like solve a problem like that?
Yep.
Does it make sense like to always use a UUID for primary key then?
Yeah, so good question. This will be the last one, then we can take stuff outside. But the question is, hey, you talked about using meaningful attributes in your primary key. You also can't change that primary key. What if you have something mutable, like a username in your application? How do you handle something like that? It's a little trickier, harder to handle there. What you might do is just sort of bite that cost of if someone wants to change their username, you go fetch that item, you write it as a new user, and then you delete their old user, something like that. You could do that. You could also, you could maintain like sort of like there's a pattern where you have like a dummy record that's basically just maintaining uniqueness on a particular attribute like the username. And that might not be your user item. Maybe you're usually fetching it by some other value, but at least would maintain that uniqueness for you, help you with something like it's a little harder to get into on this.
Keep a pointer from the dummy record to the actual one?
Yeah, yep, something like that. So it depends a little bit. It's doable, but yeah, that can be a hard case where you have something that you want to be unique but also mutable because it's like, do I put in my primary key or not? It's a little harder problem, but it's doable. And usually those type of operations tend to be more like control plane-like operations where if they're a little bit slower to make an update type thing, it's okay. Hopefully, but yeah. So if I have to do a read first, delete, insert, things like that, it can be doable. That's all we have time for, but I'm happy to answer questions outside too.